Finally, let's look at the second derivative information for this function. The first derivative was equal to x squared minus 2x minus 3 over x minus 1 squared. So we need to take one more derivative of this. Once again, we'll use the quotient rule. It'll be the bottom times the derivative of the top minus the top times the derivative of the bottom. Now here I have to use the chain rule. So we'll have 2 times x minus 1 to the first times the derivative of the inside, which is 1, all divided by the bottom squared. Now before I go through and start multiplying all this out, notice that I have a common factor of x minus 1 here and here, which I'll be able to factor out and cancel with one of these x minus 1s in the denominator. So let's do that. Let's factor out an x minus 1 from the numerator and see what remains inside. In the first term, I'll still have an x minus 1, as well as this 2x minus 2. Over here, I am factoring out this x minus 1, but I'll still have 2, and I'll have a trinomial. And then I have the x minus 1 to the fourth downstairs. Now I can cancel this x minus 1 with one of these, leaving me with 3 downstairs. And now let's multiply things out and simplify in the numerator. Multiplying here, I have 2x squared minus 2x is minus 4x plus 2. And distributing the negative 2, negative 2x squared plus 4x plus 6. And look, 2x squared minus 2x squared is 0. Negative 4x plus 4x is 0. And 2 plus 6 is 8. So my second derivative simplifies to 8 over x minus 1 cubed. Let me capture that up here, and then I'm going to erase this part. So pause the video if you don't want me to erase this before you get a chance to copy it down. Okay, I'm going to erase. So now, the places where the second derivative can change sign are the places where the second derivative is either undefined or 0. Well, this is undefined at x equals 1, which we recall is a vertical asymptote. And notice that since the numerator is never 0, this function is never 0. So the second derivative is never 0. So when we draw a number line for the second derivative, there's not a lot to put on here. We're going to indicate that there's a vertical asymptote at 1, and that's it. So let's look at the intervals. We'll have one interval from negative infinity to 1, and a second one from 1 to infinity. In the first interval, I can choose maybe x equals 0. In the second one, x equals 2. We can substitute those into the second derivative. So f double prime of 0 is 8 over negative 1 cubed, which is negative 8. So the second derivative is negative on this first interval. And plugging in 2, f double prime of 2 is 8 over 1 cubed, which is 8, which is positive. So when we look at concavity, the graph is concave up when the second derivative is positive. So the graph is concave up from 1 to infinity, and concave down when the second derivative is negative. from negative infinity to 1. So the graph is concave down, then there's a vertical asymptote, then the graph is concave up. Notice that matches perfectly with the sketch that we had drawn so far. Concave down, vertical asymptote, concave up. Remember that the points of inflection are going to be the points on the graph where the second derivative changes sign. Even though the graph changes sign at the vertical asymptote, that's not a point on the graph. So that means that there are going to be no points of inflection. So that fills out almost all of the function summary sheet, with one exception. We haven't talked about the range. So let's go back and look at the graph and determine the range. Working from bottom to top, the range goes from negative infinity up to here, which is negative 3, and then there's a gap. Then it begins again at y equals 5 and continues to infinity. So the range is from negative infinity to negative 3. That negative 3 is included, together with from 5 to infinity. Let me hold up what the completed function summary sheet should look like. A couple of problems that I'd suggest that you do now are these. Example 3, try this one. F of x equals x squared minus 6x plus 12 over x minus 4. And example 4, f of x equals x to the 4th minus 5x squared plus 4 over x squared. The first one is going to work out very much like example 2, the one we just finished. Example 4 has some kind of unique features. This one's not going to have it will have a vertical asymptote, but it will not have horizontal or oblique asymptotes. Notice here that the degree of the numerator is 2 bigger than the degree of the denominator. So give those a try, and I will post the completed function summary sheets for you on Blackboard.